Brief introduction to work and energy. Work, energy, forms of energy, power, recapitulation.
We had already studied about the ways of describing motion of objects. There is another concept, work, which will help us to understand many natural processes. The closely related to work are energy and power. In this chapter, we are going to deal with work, energy, and power. What is work? In a day-to-day life, any physical or mental activity is considered as work. There is a difference in the way we use the term work in our day-to-day life and the way we use it in science. From the science point of view, we can define work when any object moves through some distance in the direction of applied force. Vivek is preparing for his examinations, while on the other hand, Varun is playing in the playground. Do you think that both of them are working? Work has a different meaning in science than it does in daily life. Though Vivek kept studying for hours, but the work done by him was zero, while Varun had done work by playing in the playground. In physics, work is said to be done if an object moves some distance in the direction of applied force. Let us consider some more examples to understand scientific conception of work. When a force is applied on a carton placed on the table, it moves through some distance. Hence, work is said to be done. Again, push a book kept on the table. The book moves through a distance. You exerted a force on the book and it got displaced. Hence, work is said to be done. A closer look from the previous discussions reveals that the two conditions need to be satisfied for work to be done are: a force should act on an object. The object must be displaced. Mathematically, work done on an object is defined as the product of applied force and displacement of the body in the direction of force. The SI unit of work is joule or Newton meter.
Suppose a constant force, denoted by F, acting on an object produces a displacement in the object along the positive x direction, denoted by S. Then the work done, W, is equal to the product of F cos theta with S.
Work done by a constant force. We do work when we push a box and it gets displaced from its position. Here, the applied force is denoted by F, while the displacement of the box is denoted by S. Thus, work done is equal to F multiplied by S. Will the work be same if the force is applied at an angle to the object? We again move the box by applying the force F, but this time at an angle to the object. As the force applied in the horizontal direction in which the box is displaced is F cos theta. Thus, work done is equal to F cos theta multiplied by S. Thus, work done by an object is equal to the product of force and the displacement produced by it in its direction of application. Let us define 1 joule. If applied force of 1 Newton on an object causes a displacement of 1 meter, then work done is said to be 1 joule. Let a force of 10 Newton be applied on a wooden box. On applying the force, the displacement produced in the box is 5 meter. The work done in this case can be calculated simply by using the formula for work done. There are many situations in which work done by the force is taken as positive, negative, or zero. A person wants to pierce a nail in his room's wall. As the moving hammer strikes the nail, it moves in the direction of the applied force. Thus, the work done is positive as the force exerted and direction of motion of the object is same. So the nature of work done is positive. Now, as the nail is struck by the hammer, the nail also exerts a force on hammer. Thus, the work done is negative as the applied force and the direction of motion of the object is opposite. So the nature of the work done is negative. Net work done on the nail by the hammer is positive, while the net work done on the hammer by the nail is negative. Here, the boy is trying to push the heavy box. Though he applied force on the box, but the box didn't get displaced from its position. As the applied force could not produce any displacement in the object, so work done is zero. When a ball rolls down on a smooth surface, then the frictional force is zero. Though the ball has covered a larger distance, but as the force applied is zero, the work done is also zero. A porter applies force in upward direction to lift the luggage from the ground, and luggage also gets displaced in the same direction. Thus, work is done. But as the porter starts walking after keeping luggage on his head, work done becomes zero. Do you know why? In this case, the porter applies force in vertical direction to balance the weight of the luggage, but no displacement is produced in the luggage in the direction of force. Thus, work done is zero.
Using the formula of work done, can we calculate the total amount of work done by a laborer who carries 10 bricks of 1.5 kg each to the roof of a building 50 meters high from ground?
The word energy is widely used in our daily life, which has precise meaning in science. Energy is defined as the capacity of a body to do work. A body in motion has more energy than a body at rest. There is a loss in energy of a body on doing work, while the body on which work is done gains energy. The energy possessed by the body can be utilized in applying the force on another body. Hence, as the body receives energy, it will be able to do some work.
Units of energy. The energy possessed by the body is its capability to do work. This implies that the unit of measuring energy is the same as that of work. So energy is measured in terms of joule. Using a video, let us try to know about the different forms of energy.
Energy is the capacity to do work and is required in every activity of our life. Energy is mostly needed either in the form of heat or electricity. For example, we need heat energy for cooking food, which is obtained by burning the fossil fuel such as cooking gas. To run different home appliances, we need electricity which is obtained from different power plants such as hydropower plant, thermal power plant, etc. Sun is the ultimate source of energy called renewable source. The energy obtained from natural sources like wind, flowing water, tides, etc. are directly or indirectly obtained from the sun. The fossil fuels such as coal, petroleum, and natural gas are non-renewable sources, as these sources, once exhausted, cannot be reused. Energy is mainly classified as kinetic energy and potential energy. Kinetic energy is the energy possessed by an object by virtue of its state of motion, such as a ball in motion. The potential energy is the energy possessed by an object by virtue of its position, such as a compressed spring. One form of energy can be converted into another form. When the string of the arrow is released to shoot an arrow, then the potential energy of the bow changes into the kinetic energy of the arrow, due to which it comes into motion. We can obtain the energy into required form from the forms of energy available to us. When coal is burnt, then its chemical energy changes into light energy and heat energy. Similarly, electrical energy converts into light energy when an electric current is passed through the bulb.